Hello and welcome to your lecture on Learning Outcome 2. Carry out calculations with numbers up to 1 million, including strategies to check answers, including estimation and approximation. So, in this lesson, your objectives are to be able to round to 1, 2 and 3 decimal places and significant figures, to add, subtract, multiply and divide by 2 or 3 digit numbers, including decimals, multiply and divide by powers of 10, and use estimation and approximation to check your answers. So let's get started then. Let's start by rounding then, shall we? Rounding to the nearest whole number, the nearest 10, 100 and 1000. That's what we're going to start with. So let's start with the nearest whole number. When rounding to the nearest whole number, look at the right of the decimal point. If the digit is 5 or more, round up to the next whole number. If the digit is 4 or less, the whole number stays the same and the value technically rounds down, just stays the same. So basically, once you've rounded down, you can just remove the numbers after the decimal point. Okay, there are 4 examples here. If you'd like to have a go at them, you can pause the video, round these to the nearest whole number, and then press play for the answer. Okay, if you've had a go at that. So let's look at our example, our explanation. It says, when rounding to the nearest whole number, look at the right of the decimal point. So, looking at 4.69, we're looking at the number to the right. Is this closer to 4 or 5? Is 4.6 closer to 4 or 5? If the digit is 5 or more, it says, we round up to the next whole number. Okay, so that's 5 or more, that's 6. So we would round up to the next whole number. So we would say that that's 5. Okay. If we're looking at 27.33, again, going back to our explanation, it says we look at the number to the right, which is this one. If it's 5 or more, we round up to the next whole number. Or, if the digit is 4 or less, the whole number stays the same and we remove the extra digits after the decimal point. So this is 4 or below, so we would just leave that as 27. We then remove the rest of the numbers. Looking at 149.387, again we look at the digit to the right, which is the 3. That's 4 or below, so we leave it as 149. Finally, we've got 271.7. We look at the number to the right of the decimal point. If it is 5 or more, we round up to the next whole number. The next whole number, so basically this is 271.7, so the next whole number is 272. So our answer would be 272. Okay, so rounding to the nearest whole number isn't too difficult. If you need to practice that, then I suggest you do so. Let's have a look at rounding to the nearest 10. When rounding to the nearest 10, we look at the units column. It's always the column to the right. Okay, so as we were looking at just here, it's always the one next to the number we're looking at. Okay, it's always the one to the right. Even though this is after the decimal point, it will always be after the decimal point. Okay, but if we're rounding to the nearest 10, then we look at the tens column and it's always the one after that that decides whether we round up or not. So when rounding to the nearest 10, we look at the digits in the units column, the end column. If the digit is 5 or more, we round up to the next 10. If the digit is 4 or less, we round down and we leave it as it is. So round these numbers to the nearest 10. Pause the video and have a go and press play for the answers. Okay, so I'm going to change my colour because I hate red. 43. Remember, we look at the number in the units column. We must remember that this is units, this is tens. Okay, if we had any more, there'd be hundreds, maybe thousands. Okay, but it was always the units column. When we're doing to the nearest 10, this is the tens column. It's always the number, it's always the value next to that. So 43. If the digit is 5 or more, so we're looking at the 3, if the digit is 5 or more, we round up. If it's 4 or less, we leave it as it is. So 43, well 3 is 4 or less, so to round it to the nearest 10 would be 40. We're trying to say, is it closer to 40 or 50 when we round to the nearest 10, because they're tens. Okay. So then if we look at 65, we're saying, is it closer to 60 or 70? Okay. Now in this case, it's smack bang in the middle, but the rules apply. If the digit is 5 or more, we round up. So 5, the units column, remember, 65, we look at the units column, and because it's a 5 or above, we round up to the next 10. The next 10 is 70. Okay. Now then, it gets trickier when we're looking at numbers, with hundreds in. So this is our hundreds, this is our tens, this is our units. So the hundreds column doesn't change because we're not rounding anything in the hundreds. Okay, we're still only rounding the tens column. But in order to round the tens column, remember we look at the units. If it's 5 or more, so it's a 4 in this case. If it's 5 or more, we round up. If it's 4 or below, we leave it as it is. So is it closer to 230 or 240? Okay, it's only the tens we're rounding. And because it's a 4 or below, we leave it as it is. So it's closer to 230. Okay, we round down. And then the last one, 327. Okay, we're rounding the tens column, so we look at the units. That's a 7. 7 is 5 or more, so we round up. Okay, so the 100 stays the same. That's 3. But because that's a 7, we're saying, is it closer to 320 or 330? Well, because that's a 7, we round up, saying it's closer to 330. All right. Okay, so that's rounding to the nearest 10. Let's have a look at rounding to the nearest 100. Now, the same rules apply. However, when we're rounding to the nearest 100, we look at the tens column. It's still the one next to the hundreds column. It's just the one to the right. Okay, but sometimes it helps you to remember hundreds, tens and units if you do it this way. Okay, and again the same rule, if it's 5 or above, we round up. If it's 4 or less, we round down. So here are some examples. Why don't you pause the video and have a go at these, rounding them to the nearest 100 and see how you get on. Okay, so first of all, looking at 435. Remember, we're rounding the hundreds column, but we always look to the right, the one to the right. Okay, so this is our units. We don't need that anymore because we're not rounding tens. This is our tens and this is our hundreds. So if we're rounding to the nearest 100, we look at the tens column. The tens column is a 3. So this is asking you, is it closer to 400 or 500? Because we're rounding to the nearest 100 now. Because that's a 3, it's below 4 or below, we round down. Okay, so it's closer to 400. Okay. 667 then. Again, it's asking you, is it closer to 600 or 700? Hundreds, tens, units. Because we're rounding to the nearest 100, we look at the tens column. It's a 6. If it's 5 or above, we round up. Okay, so this 100 now becomes 7. 700. All right. Now, we've then got some digits here that have got thousands in. So 2,345, 5 units, 4 tens, 3 hundreds and 2 thousands. The 2,000 doesn't change, that stays the same, so I can put that in straight away because actually all we're doing is rounding to the nearest hundred. Is this closer to 2,300 or 2,400? That's what it's asking you. Remember, we look at the tens column. So the tens column is a 4. Because that's a 4, the hundreds column rounds down, or it stays the same. So we just keep the 3 as it is. So it's 2,300. The rest becomes zeros. And then finally, 3,270. Again, you've got thousands, hundreds, tens, and units. And because we're rounding to the nearest hundred, the 3 on the 3,000 stays the same. And we look at the tens column to decide whether it's closer to 3,200 or 3,300. Remember, if it's 5 or more, we round up. So the hundreds column rounds up 1. So it'd be 3,300. Okay, hopefully you're doing well so far. All right, let's move on. Rounding to the nearest 1,000 now. When rounding to the nearest 1,000, we look at the hundreds column. Again, it's just the one to the right. If the digit is 5 or more, we round up to the next 1,000. If the digit is 4 or less, the thousands digit stays the same, or if the value rounds down. Here are 4 examples. Why don't you pause the video, have a go, and see how you get on. Okay, if you've had a go at that, let's have a look at these examples. We have 4,358. Here's your thousands, here's your hundreds, here's your tens, here's your units. Remember, because we're now rounding to the nearest 1,000, it's this one we look at to decide. Is this closer to 4,000 or 5,000? Okay. If the digit to the right of the column that you're trying to round, so in this case the hundreds column, is 5 or more, we round up. But it's not. It's 4 or below, it's a 3. So we leave it as it is. We leave that 4 as 4,000. Okay. Looking at the next one, 6,670. Again, we've got thousands, hundreds, tens, and units. Is this going to be closer to 6,000 or 7,000? We look at the digit next to it, the 6. 5 or above, that is. Okay, so if it's above 5, we're going to round up. It's going to be 7,000. Okay. All right. So 2,345. Thousands, hundreds, tens, units. Is this closer to 2,000 or 3,000? Okay. Again, look at the hundreds column. It's a 3. If it's 4 or below, we'll leave it as it is, so it'd be 2,000. And then the last one, 3,570. We've got our thousands, hundreds, tens, and units. Is this going to be closer to 3,000 or 4,000? Look at the number next to it, that's a 5. If it's a 5, we round up. So it must be 4,000. Okay. Right, I hope you're still with me so far. That's not too bad, rounding the nearest whole number, 10, 100 and 1,000. What we're going to do now is we're going to have a look at rounding to certain decimal places. So, you still use the same rule. When rounding numbers to a given number of decimal places, count the given number of places to the right of the decimal point. Then look at the next digit on the right. Made a mistake there. As before, if the digit is 5 or more, round up. If the digit is 4 or less, the digit at the given place value stays the same and the number rounds down. Now, let's look at some examples and we'll go through that explanation again. If you want to pause the video and try and round these to 1 decimal place, please do. Okay, if you've done that. Now, we've got here 4.69. Looking at our explanation, it says, count the given number of places to the right. Well, what it means by that is, if you're being asked to round to 1 decimal place, then you basically need to stop there after 1 decimal point. After 1 number after the decimal point, sorry. Okay. And if you need to stop there, we then need to look at the number on the right of it again and think, does that stay as a 6 or does it round up to a 7? Okay, because we're rounding to 1 decimal place. This is the number we're rounding. The 4 stays the same, we don't move that, we don't change that. So, if it's 5 or above, we round up. So that 6 actually becomes a 7. So our answer would just be 4.7 to 1 decimal place, because we only want 1 number after the decimal point. That's what that means. Okay. Now, if we're looking at 27.33 to 1 decimal place, again, we only want 1 number after the decimal point. However, this is the number we're going to round. We need to look at this number to decide whether it stays as it is or rounds up. Well, that's a 3. And remember, if it's 4 or below, we leave it as it is. So this 3 would stay as it is. And we'd see this written as 27.3 to 1 decimal place. Okay. Then we've got 149.387. Again, you're only rounding to 1 decimal place, so we actually just need to stop there. So are we going to leave that 3 as it is, or are we going to change it to a 4? Look at the number on the right, it's an 8. 8 is 5 or above, so it rounds up. So it would become 149.4. Okay. To 1 decimal place, sorry. And then finally, on the last one, we have 271.743. Again, we are rounding to 1 decimal place, so we're going to stop 1 number after the decimal point. And we're going to decide whether this stays as a 7 or it changes. And we look at the number to the right. That's a 4. And we know that if it's 4 or below, it stays the same. So 271.7 to 1 decimal place. Okay, so when rounding to 1 decimal place, we're basically just keeping 1 number after the decimal point, but we need to decide whether it's going to be rounded or not. And we decide using the number on the right of it. Okay. All right. What about 2 decimal places then now? Why don't you pause the video and have a go at these ones? Okay, if you've had a go at those, let's have a look at rounding these to 2 decimal places then now. We've got 4.6931. So it's the same concept, but this time what you're doing is you're counting 2 numbers after the decimal point, because it's 2 decimal places. Okay, so it's actually this number that's going to be rounded or not. And again, the way you decide it is by looking at the number to the right. So 4.69, or are we going to round it up? Well, that's a 3. So we're going to leave it as it is because 3 is 4 or below. So it's actually 4.69 to 2 decimal places. All right. We've then got 27.325. Again, 2 numbers after the decimal point now. So you must count those 2 numbers after the decimal point. And it's the second one that we're going to either round or not. We look at the number on the right. Are we rounding it up or leaving it as it is? Well, we know that if it's 5 or above that number, we round up. So that 2 becomes a 3. So our answer becomes 27.33, okay, to 2 decimal places. Next, we've got 149.387. We're going to round our numbers to 2 decimal places. Alright, so we count 2 numbers after the decimal point. This is the number we're going to round. We look at the number on the right. It's 5 or above because it's a 7, so that 8 becomes a 9. So 149.39 to 2 decimal places. And then the last one is 271.743. And again, after the decimal point, we need 2 numbers. We're going to round, or we're going to look at the 4. Are we going to change the 4? And we look to the number on the right, it's a 3. If it's 4 or below, we know we leave it as it is. So that one would just be 271.74 to 2 decimal places. Okay. Alright, so that's 2 decimal places. The final one then is rounding to 3 decimal places, which is exactly the same concept. So pause the video and have a go, and press play for the answers. Okay, 3 decimal places then now. 3 decimal places means 3 numbers after the decimal point, as I'm sure you've guessed. So for the first one, it's 4.6931. So we're going to count 3 numbers after the decimal point, and we're going to try and stop there. Okay, so this is the number we're going to round. The number to the right of it is a 1. Again, if it's 4 or below, we leave it as it is. So 4.693 to 3 decimal places. Okay. The next number, 27.3253. We will count 3 places after the decimal. Okay. 300, so 27.325. This one is the number that we're going to round, and we look at this one to decide. Again, it's a 3, so it's below 4, so we're just going to leave it as it is. 27.325. 3 decimal places. Next, we've got 149.3867. And we are going to count 3 places after the decimal point, and we need to stop there. We're going to round the 6. We'll look to the number on the right, and it's a 7. So if we know it's 5 or above, we round up. So that 6 will change to a 7. So 149.387 to 3 decimal places. Okay. And then the last one is 271.7436. And we're going to count 3 places after the decimal. Okay. So then we're going to decide, this is the number I'm going to round. This is the number that's going to determine that for me. It's a 6. And again, we know if it's 5 or above, we round up. So that 3 will become a 4. So 271.744 to 3 decimal places. Okay. All right. So that was done. Hopefully you've got the hang of decimal places now. That was quite a few examples. Let's move on to looking at some significant figures. Okay. I'm not going to do loads of these because they can be a little bit tricky. Now then, the first significant figure, okay, is the first non-zero digit in a number from the left. Okay, I'll show you what that means in a minute. The second and third significant figures follow immediately after the first. Okay, they may or may not be zeros. So the first significant figure can't be a 0, it has to be a number. But the second and third significant figures can be zeros. And then you just use the same rules. So here's some numbers. I want you to, if you want to pause the video and copy this table and have a go, then please do. Okay, and then press play for the explanation. Okay, if you've had a go at that, we are going to start by doing one significant figure. All right, so looking at this first example, we'll go through all of them, doing one significant figure, then two, then three. All right, so one significant figure is the first number you come to, not a zero, an actual number. Okay, so the first number we have here is 9.3156. Okay, so our first significant figure is going to be 9. So to round to one significant figure, I look at the 9 and I look at the number next to it. If that's a 4 or below, I leave it as it is. But if it's 5 or above, I round up to the next number. What is a 3? So that's 4 or below. So that's going to stay as a 9. Okay. Now the next number, again, my first significant figure is the 6 because it's the first number I come to. It's not a 0. Okay. If I look at the number next to it, it's a 3. So my 3 means that I leave it, I round down. So in this case though, right, so the first one was a decimal, 9.3. So 9 would have been my answer because that 3 disappears because it's 9 point something, it's a whole number already. With a decimal at the end. This next number is just a whole number. So because this is a 3, to round to one significant figure, I would keep my 6 as it is, but it can't just be 6 because it's not got a value of 6, it's a value of 6,000. So I have to write in 6,000. Okay. If that 3 was a 5, then the 6 would have been rounded up to a 7, but you still would have just had zeros on the end. Okay. Because that still needs to represent the value of it. I can't just write 6 because it's not the same as 6,000. Okay, the third example, my first significant figure is actually this 7. Okay, it's not the 0. I'm not allowed to use 0 as my first significant figure. So this is going to be 0 point something because again, you've got to hold the value. Now if I look at the number next to that, it's a 3. Now that means that that 7 is going to stay as it is. Okay, and the rest you can put zeros if you want to, but it doesn't mean anything, so there's not really much point. So 0.7 would be your answer there. And then this last one, my first significant figure is 7. So I then look at the number next to it, that's a 5. Again, if it's 5 or above, we round up. So that 7 actually becomes an 8, and then I have to put 2 zeros in to make sure I keep the value of the number. Okay, this is hundreds. This is thousands. I can't just write 6, I can't just write 8. It has to be the value of the numbers, how many digits there are. Okay? So to round to two significant figures, what we're technically doing is looking at the second digit along. So with the first significant figure, we only look at the first number, but with the second significant figure, we look at the second one. So all we need to do here is, for this first question, 9.3156, we're going to look at the 3 because that is our second significant figure. Okay, and then we look at the number to the right of that one to decide whether we round it. So would it be 9.3 or 9.4? Well, it would be 9.3 because it's a 1 next to it, and if it's 4 or below, we leave it as it is. For this next one, we're going to look at the 3. Okay, is it going to be 6,300 or is it going to be 6,400? That's the question. We look at the digit to the right and it's a 5. So because that's a 5, the 3 rounds up. So it becomes 6, 4 and then 0, 0 on the end. Because we've rounded it, those numbers have to be zeros. Okay. And then here, the second significant figure is actually 3. Okay, because 0, oh wait, yeah. Okay, so looking at the next one, the second significant figure is actually 3 because the first significant figure was 7. It couldn't be the 0. So the second significant figure is 3. Okay, so then we'd look at the digit on the right and that's a 5. So that 3 would round up to a 4. So it'd be 0.74. And then on this last one, the second significant figure is 5. Okay, so we would then look at the number next to it, which is an 8. So that 5 would round up to a 6, and then we'll put a 0 on the end. Okay, so you remember you've got to keep the value of the number. If this is a 6,000s, it's got to remain a thousands. Okay, this is a 700 or hundreds, it's got to remain a hundreds. All right, finally then, let's look at 3 significant figures. If we, let me change my colour one more time. Blue. 3 significant figures, we look at the third digit along. So for this first one, it's the 1. That's the third digit along. That's our third significant figure. Is that going to remain a 1? If we look at the number next to it, it's a 5, which means that 1 gets rounded up. So it'd be 9.32. Okay. Now looking at 6,350, our third significant figure is the 5. But because the number next to it is 4 or below, the 5 stays as it is. So 6, 3, 5, and then 0. So it would just stay like that. We have to have the 0 on the end because it's a thousands. Okay, if we took the 0 off, it'd give us 635, and that's not the correct value of the number. Now this next one, our third significant figure is 5, and there's nothing after the 5, so that would just stay as it is. 735. And for the last one as well, the 8 is our third significant figure, and we can't change that either, so that would just remain 758. Okay. Again, if you need to practice those, watch that video as many times as you need to and try and get some practice in of rounding, especially to 1 and 2 significant figures, because you'll be asked to do that in the exam. Obviously, once we start looking at exam questions, they will be asking you to round to 1 or 2 significant figures anyway, and I'll be going through them. So estimation is usually done by rounding each digit to 1 significant figure. So a bit of practice here. So it wants you to estimate the answer to this question. 273 times 49 over or divided by 28. When we round to 1 significant figure, remember, we look at these first digits. If we're going to round them all. If you want to pause the video and have a go at this, then go ahead and do that now. And then press play for the answer. Okay, let's just quickly round these first. So 273. We're going to look at the first digit, which is 200. Okay. We look at the digit next to it. That's a 7, which means we round this up to 300. So that becomes 300. We look at 49, 1 significant figure. We look at the digit next to it. It's a 9, so that rounds up, and that becomes 50. Okay, again, you must keep it. This is hundreds. This is tens. We can't make that 5 and that 3. It won't work. And then 28, again, we look at the 2, and the digit next to it is an 8, so we round that up to a 3, so that becomes 30. Okay, and then because you've now rounded to 1 significant figure, you can then do the calculation. So 300 times 50, well, you can do 3 times 5, which is 15, and then add on your 3 zeros. And all of that is divided by 30. Okay, and then to make it easier, I'm just going to take off those 2 zeros, 1 off the bottom, 1 off the top, giving us 1,500 divided by 3. If I do 1,500 divided by 3, it will give me exactly the same answer as if I'd have done 15,000 divided by 30, because I've divided them both by 10 to get rid of those zeros. So it's the same question. 15 divided by 3 is 5, and then add your 2 zeros on. So it's 500, which you probably would have known that anyway. Okay? So that's how estimation works. If you get a question like that, make sure you listen in the exam when they say estimate. People just literally sit there and do 273 times 49 and then divide it by 28. You'll be there forever. Okay? So listen to what they're saying. Estimation means rounding. Okay, so what about this question then? Neve needs 4 tins of paint to decorate her flat. Each tin costs £38.99. Neve has £150. Use estimation to decide whether she has enough money to buy the paint that she needs. Show you're working. So you can pause the video here and have a go and then press play for the answer. If you've done that, let's have a go at it then. So let's look, first of all, it wants us to estimate, okay? Use estimation. We've got £38.99. All right. So £38.99, look at one significant figure, remember. Looking at the first significant figure is a 3. So to round it, we look at the number next to it, which is an 8. So that 3 would technically be rounded up to a 4, giving us £40. So we'll just round that up to £40. Okay. So £40 per tin, estimated. She needs 4 tins. Is that right? Yeah, 4 tins. So 40 times 4. Well, 4 times 4 is 16. Add the 0 on is £160. So no, she doesn't have enough. Okay, because, I mean, it depends on how much they want you to explain in the question, but you probably won't have to explain too much because you've shown it here. No, she doesn't have enough because she needs closer to £160. And she only has £150. Sorry, £150. Okay, lovely. So I hope you're doing well on these. This isn't too bad of a week. It's not too difficult. All right, we are almost finished. This is the last one. So estimate the answer to each of these calculations. Pause the video, have a go at these. You should be able to do this now, and then press play for the answer. Okay, so what we've got here then for the first one is rounding them all to one significant figure. You should have got 10 for this one because it's 9 and then you've got a 7 there, so you'd round it up. So 10, and then this one is a 4, but this is an 8, so that would round up to a 5, making it 50. And then with this last bit, 0.32, this is your first significant figure, okay? And this is a 2, so it would actually stay the same. So that 0.3 would stay like that. Okay. And then what we'd have is on top you'd have 60 over 0.3. Now, I know that looks a little bit tricky, but what we could do is times everything by 10. Because if I times everything by 10, that makes that 600. And remember, when you times by 10, you move the decimal point, making that 3. Okay. So 600 divided by 3 is 200. So that's your answer for that one. Okay. Now, for the next one, again, you're rounding to one significant figure. So looking at the 3, and then the number next to it is a 0. So the 3 stays the same. So that would be 300. This is 2.93. So looking at the number next to the 2, it's a 9. So I'd round that up to 3. Okay, everything else can go because I've rounded up. And then this bottom one, this is my one significant figure. So this is a 1, so that 5 stays the same, so it'd actually be 0.05. Okay, now, you've rounded them to one significant figure. Now do the calculation. 300 times 3 is 900. 900 divided by 0.05. If I've got 900 divided by 0.05, what I could do is times them both by 100. Okay, which I know sounds ridiculous, but if I times them both by 100, and it means that that becomes a 5. So 900 times by 100, I add on 2 zeros, and 0.05 times 100 is 5. So you've got 90,000 divided by 5. Okay, again, sounds mad, but if we do 90 divided by 5, how many 5s into 9 is 1, remainder 4. Okay, so you've got 40. How many 5s into 40 is 8. So your answer is 18, but then you've got these 3 zeros. So your answer is 18,000. Okay. All right, I hope you did well on that and you understood everything I went through there. The rounding to one significant figure and two significant figures might be a bit tricky, but once you get your head around it and using these little tricks to help you with your calculations, like multiplying by 100 or multiplying by 10, okay, you will be able to do things much quicker. Okay, so the first thing we're going to look at is multiplying and dividing numbers by the powers of 10. All you need to, if you want to pause the video and have a go at this first, then please go ahead. But all you need to remember is if we times by 10, we move the decimal point one place, or we add a 0. If we times by 100, so we move the decimal point 2 places, or we add 2 zeros. And if we times by 1,000, we move the decimal point 3 places, or we add 3 zeros. So pause the video and have a go, and then press play for the answers. Okay, if you've had a go at those, 5.6 times 10, that's got a decimal point in it, so we just move it one place this way, and it gives us 56. 45 times 10, that doesn't have a decimal point in it, so we just add a 0, giving us 450. 19.3, that's got a decimal place, and we're timesing it by 100, so we have to move the decimal point 2 places. So if I just write 19.3 over here, and if there's one place, then there's another. So we have to put a 0 in where that archway is. So it would be 1,930. Okay, if we times that by 100. And then the last one is 78 times 1,000. And because it's timesing by 1,000, it doesn't have a decimal point in there. So we just add 3 zeros because it's 1,000. So that would be 78,000. Okay, easy as that then. Moving on. Okay, so in this case now we've got two examples where we're still multiplying by powers of 10, but you've got to do it a little bit differently. So pause the video and have a go at these ones, and then I'll go through the answers. Okay, so for this first one, we could do this in two ways. We could do 5 times 3, which is 15, because we can just take this and this, and then add the zeros. That gives us 1,500. Or what we could do is 50 times 10, because we would just take this, like this 10 here, which gives us 500, and then we could times it by 3 because it's 30. Okay, giving us 1,500. So it just depends which way round you want to do it. I prefer this way, it's quicker. And then this next one here, that one's actually really nice because we're timesing by 20. So you could first of all do 5.2 times 2. Okay, just using this 2, giving us 10.4. Okay, and then we times by 10, which is this 0 here, giving us 104. Okay, so because it's got a decimal point in it, we can't just add a 0 to the end, we have to move the decimal point one place instead. So your answer would be 104. Okay, so next we have some division. Now, before, when we times by 10, we moved one place that way, okay? And if we times by 100, we moved 2 places, or added 2 zeros. And if we times by 1,000, we moved the decimal point 3 places, or added 3 zeros. Well, that's when we times, but when we divide, it's the opposite way around, okay? Sorry, that's meant to be a division. If we divide by 10, we go one place backwards or take off a 0. If we divide by 100, we go 2 places backwards or take off 2 zeros. And if we divide by 1,000, we go 3 places backwards or take off 3 zeros. So why don't you pause the video and have a go at those, and then just press play and I will go through the answers. Okay, so 17.8 divided by 10. If we're dividing by 10, it's only got 1 0, so we go one place back, and our decimal point ends up there, giving us an answer of 1.78. Nice and easy. If we have 84 divided by 100, okay, so we go from the end of the number. 100 has 2 zeros, and we go, there's no decimal point in it, but we've got to go back. So we go from the end of the number just there, and we go back 1, 2. Okay, and our decimal point would end up there, giving us 0.84. And finally, you've got 19.6 divided by 1,000. So we go from the decimal point in this case, because there is 1, and we have to go back 3 spaces. So just be careful here. We go 1, 2, and then 3. So your decimal point would end up there, which means you've got a space here for a 0. And if the decimal point's there, then it will be a 0 there as well. So it'd be 0.0196. Okay? So I hope those are quite straightforward and easy to understand. I'm sure you've done them loads of times before, so I didn't want to go into too much detail on that. Okay, we have 2 extra examples now of dividing by different numbers, but still powers of 10. So pause the video again and press play for the answers. Okay, so for the first one, personally what I would do is here is I would take off these 2 zeros. Okay, I'd take off the 0 on the 20 and one of the zeros off the 8,000. That leaves you with 800 divided by 2. 800 divided by 2 is just half of 800, which is 400. That's the right answer because I took a 0 off both of them. We don't have to do anything else to that. Okay, that's that one. And then what you could do here is you could divide by 10 first for this second one. So 9.3 divided by 30. Okay. If we divided by 10 on both sides, we're left with 0.93 divided by 3. Okay. Because what we've done is we've taken this 9.3 and we've divided by 10, which means we've moved the decimal point that way. And then we've taken the 30 and we've divided by 10, which means we had to get rid of the 0. So we're now left with 0.93 divided by 3. And this is nice and easy because all we're going to do is put our 0 point back in, and we're going to do 9 divided by 3, which is 3, and 3 divided by 3, which is 1. So our answer would be 0.31. Okay. Again, I hope you did well on those. These kinds of questions are really good to practice because it will really get you used to using or taking off zeros and things. So I'll try and put a worksheet on for that just for your own practice. It's not a mandatory worksheet, but if you want to practice that, then I'll put one up. Okay, so moving on to just some extra examples. Now, I just want to remind you that when you multiply by a number that's between 0 and 1, so these are all very small numbers, the answer is smaller than the starting number. Okay, I'm going to give you some to have a go at in a second. But here is 7 times 0.1, and these are really easy because all you're saying is, it's like saying 7 times 1 is 7. Well, 7 times 0.1 is 0.7. 7 times 0.01 is 0.07. And 7 times 0.001 is 0.007. Okay, so very simple. What about these ones? So we've done some multiplication here. You've got 3 answers that are all very small, okay? Small answers because you are multiplying by a number that is less than 1, okay? Timesing by a number less than 1. Now, when you do that, your answer becomes smaller than your starting number, okay? So it's good to remember these. When you divide, like on this page, by a number between 0 and 1, the answer is always bigger. So 9 divided by 0.1. 9 divided by 0.01. Why don't you pause the video and have a go and see what your answers are? And then I'll press play, and see what your answers will be once I go through them. Okay, if you've had a go. So again, when you're dividing by a smaller number, okay, your answer will always be larger. In this case, it will be larger by a factor of 10. In this case, by a factor of 100. And in this case, by a factor of 1,000. Okay, so 9 divided by 0.1 is 90. Okay. 9 divided by 0.01 will be 900. And 9 divided by 0.001 will be 9,000. Okay, you're basically, it's the same as doing 9 times 10, 9 times 100, 9 times 1,000. Okay, just getting you used to using these different ways of writing out calculations, okay? So the most important thing that you can remember from these last few slides is how to times by 10, how to times by 100, and how to times by 1,000. Okay, if you know that 9 times 10 is 90, or 9.4 times 10 is 94, okay, or 8 times 100 is 800, or 8.6 times 100 is 860, okay, then you'll be fine. You need to know those. Obviously, again, you could probably say, you also need to know like 6.3 times 1,000, okay, is 6,300, okay. So you must know those main facts. If you're struggling with these, don't panic too much, but it'd be useful if you did get to grips with them. Okay, so what we're going to do now is move on to some written methods of adding, subtracting, multiplying and dividing. So again, if you'd like to pause the video and have a go at that question, please do, and press play for the answer. Okay, so let's go through the method to add these two numbers together. So when we add, it's much easier if we just use the normal column method. So we're not going to go through loads of different methods for adding. We're just going to go through one method of adding without a calculator. And what we're going to do is we're going to take our numbers 5, 2, 7, 9, and we're going to add 408. Remember to line up your thousands, hundreds, tens and units. So units here, tens here, hundreds here, and then thousands there. And then we're going to add them together. Okay. So if I just change my colour pen, you'll be able to see this. We're going to do 9 add 8, okay, and 9 add 8 is 17. So we have the answer at 17, but what we do is we write the 7 there, and we carry the 10 over to the next column, okay. We would then do 7 add 0, which is just 7, and then we would add on this 1 here, giving us 8, and 8 would go there. We've not carried anything over, so we can just move on to the next column and we can do 2 add 4. 2 add 4 is 6. And then finally, we just have 5 add nothing, so we can just put 5. So our final answer is 5,687. Done. Okay, why don't you have a go at this next one, and we are adding a decimal, some decimal numbers together here. So again, pause the video and just have a go, and then we'll go through it. Okay, if you've had a go at that, what we're going to do is we're still going to write out our numbers the same, and we need to line up our decimals. So 127.3, and then we're going to add to that 9.07. Now it looks a bit odd because you've not got a number on the end after the 3. So if it helps you, you can put a 0 there, okay, because that's technically what that means. But you must line up your decimals. And then we're just going to add in the same way. I'm also going to put my decimal in my answer there because it stays in the same place. So we do 0 add 7, which is just 7, and 3 add 0, which is just 3. Okay. We're then going to leave the decimal where it is again, as I mentioned earlier, 7 add 9. Okay, 7 add 9 is 16. Okay, so if it's 16, we're going to put the 6 there and we're going to carry the 10 over to the other column. Okay, it's because it's a 10 and a 6, we have to carry that 10 over. So we leave the 6 where it is, okay, put that underneath the 7 and the 9, and then we carry the 10 over to the next column. So then technically in the next column you would have 2, and you've got nothing there, but then you're going to add the 1. So 2 add 1 is 3. Alright. And then finally you've got 1 add nothing, so it'll just be 1. 136.37. And that's your final answer. So hopefully you got that right. Okay, so let's move on to doing some subtraction. So subtraction, or taking away, is just the same really as adding. We're going to write it out just the same. So if you want to have a go at this, pause the video and have a go, and then press play and we'll go through it. Alright, if you've done that, hopefully you got this one right. Let's write the number down, 2,791, and you're going to take away 365. Now then, there is a difference with subtraction, and I'll explain that in a minute. Well, I'll explain it now. So the first thing you're going to do is we're going to do 1 take away 5. Now, even though we know we could do 1 take away 5 and it would give us -4, that's not going to help us in this case. We want a final answer, no negatives in there, because 2,791 is quite a large number and we're just taking away 365, so there will not be any negatives. So instead what we do is we take this 9 that's over here and we take a 10 from it. So we turn that into an 8 and we add a 10 to this 1, giving us 11. Okay, so then we've got 11 take away 5. Okay, 11 take away 5 is 6, so that's what goes there. We then move on to the next column and we can do now 8, which is what we've got there, take away 6. 8 take away 6 is 2, leave that there. 7 take away 3 is 4. And then 2 take away nothing is 2. Okay, so your final answer is 2,426. And you've done. So you just need to remember that when you can't subtract, we take a 10 from the column next to it and add it to the number that we're going to use. Okay. All right, what about this one then? We have a decimal. Why don't you pause the video again and see if you can work this one out? And then I'll go through it. Okay, let's go through that then. Hopefully you've got the right answer written in front of you. 3,467.54. Okay, remember we need to line up our decimals, so 347.12. All right, so you're going to subtract those from each other. Okay, so first of all, starting at the end, we've got 4 take away 2. That's easy, nice and easy, 2. We've then got 5 take away 1, and that's 4. Our decimal goes in exactly the same place. Okay, and then we can move on to 7 take away 7. 7 take away 7 is 0. 6 take away 4 is 2. 4 take away 3 is 1. And 3 take away nothing is 3. So your final answer will be 3,120.42. Okay, so again, you might want to practice doing some subtraction. If you do, I can put a worksheet on that is not a mandatory worksheet, but you can at least have a go at them. Okay, you can have some practice. So you don't have to hand it in or anything, but you can have some practice. So you'll practice doing this method where you've had to carry over, and this method where you're doing the decimals. Okay, all right. Okay, let's move on then. We're going to do some multiplication now. So there's different methods here. We're going to start with the column method. Why don't you pause the video, have a go at doing this and in the column method way, and then press play for the answer. Okay, so the column method. The column method is where we still write our numbers out in a column, but this time we are multiplying, not adding or subtracting. So we're writing it like this. With the column method, what we need to do is we need to multiply everything on the top by everything on the bottom. So we're going to start with 4, and we're going to multiply it by 3. 4 times 3 is 12. 12 is 10 and 2. So remember, we have to put the 2 in, but then we carry the 1 to the next column. We're then going to move along to the 2 and do 2 times 3. 2 times 3 is 6, but we must add this 1 on, so that makes 7. So 24 times 3 is 72. Okay, not too bad. Okay, let's try another one. Why don't we try 27 times 33, first of all using the column method. So I'm going to start by using the column method, and then I'll show you another way of doing this. Okay, have a go at using the column method, and then I will show you another method. Okay, if you've had a go at that one, if you pause the video, we're still going to write the number in the same way. 27 times 33. It's a little bit trickier because we've got more than one number now on the bottom. So remember what I said? I said you had to multiply everything on the top by everything on the bottom. Let's start with the 7. 7 times, and we're going to do by this 3 here. 7 times 3 is 21. We put our 1 there, but we carry the 2 over to this side. Okay, so 7 times 3 is 21. I'm then going to move over to the 2 and multiply that by 3. Okay, so everything must be done by this number first. So 2 times 3 is 6, then we add on this 2, which is 8. So we put that there. Now, the next thing we need to do is I'm just going to create a new set of boxes, because what I'm going to do now is move on to multiplying everything by the other 3. This one. Because I've now moved from the units column to the tens column, I need to put a 0 in here. Okay. I'm now going to go back to the 7 up here, and I'm going to multiply it by this 3. Again, 7 times 3 is 21. So I put my 1 in and I carry my 2 over to the other side. I then move over to the 2 and I'm going to multiply that by this 3. 2 3s are 6, but I need to add my 2, which makes 8. Okay, so 810 now. So now you're left with these two numbers. You're left with 81 and 810. So you just need to add them together, and then it gives you your final answer. So if I write down 81 and 810, I'm going to add them. 1 add 0 is 1, 8 add 1 is 9, and 8 on its own is 8. So my answer is 891. Now the column method is quite tricky, okay, and people do find it very difficult to remember. And it's quite an old-fashioned way of multiplying as well. So I'm going to show you the grid method now. The grid method is where we write down our 27 times 33, but we put it into a grid, and we split it into tens and units. So instead of writing it like this, we do 27 times 33. Okay, so I've split 20 and 7 up into two tens, or 20 and then 7, and then 33 as in 30 and 3 units. Okay, and what we're going to do is we are going to multiply each section together. So I'm going to do 30 times 20. Okay, and you can do 3 times 2, which is 6. And then we add 2 zeros on. We've got this 0 there and this 0 there. Okay. I'm then going to do 30 times 7. Well, 3 times 7 is 21. And then if we just add on the 0 from the 30, it's actually 210. Okay. And then we'd go down to the 3 and we would do 3 times 20. Again, 3 times 2 is 6. And then we add the 0 on from the 20. And then finally we do 3 times 7. And 3 times 7 is 21. So all you have to do now is we add up all of the answers that we've got. We've got 600, 210, 60 and 21. So we're going to write them down here, 600, 210, 60 and 21. Okay, and I'm going to add up everything in this column. So I've just got 0, add 0, add 0, add 1. So that'll just be 1. And then in this column, I've got 1, add 6, add 2. So 1 add 6 is 7, add 2 is 9. And in this column, 6 add 2 is 8. And again, 891, you can see we got exactly the same answer here as we did here. Okay, so both methods work. You just need to find a method that works for you. Okay, so what I'm going to do now is I'm going to show you a method called the lattice method. Okay, now this method, it doesn't matter whether you've got a decimal question or a normal number without decimals, this method will still work. I'm going to show you a method with decimals, but I'm actually, instead of doing 6.24 times 8.1, I'm going to do 624 times 81. So it's quite a long-winded question, which is absolutely fine. It will still work really nicely. But the only problem is here, when we figure out the answer, we have to put our decimals back in. Whereas if it's not a decimal question, then you won't have to do that. So either way, this method will work. We just need to remember that here with this 6.24, we moved our decimal point 2 places to get rid of it. Okay, so I'm going to put 2 dp there. And then with 8.1, I've moved it 1 decimal place. So I know that altogether, when I've finished my answer, I need to put my decimal point back in 3 places. 2 add 1 is 3 decimal places in total. I'll show you what that means in a minute. So for now, we're going to do 624 times by 81. So can you see that I've drawn a grid with enough spaces to do a 3-digit number multiplied by a 2-digit number. A little bit similar to the previous grid, except I'm not using zeros. I'm not doing 600 with zeros in it, times 20 and then times 4. And I'm not doing 80 times 1. What I'm doing is I'm just writing out the digits that I need. Okay. So, and then what I've done is I've put in these diagonal lines, 1 through each box. Okay. This is a good method when you've got really large numbers. So what we're going to do is we're multiplying these together. Now the first thing we're going to do is we're going to do everything multiplied by the 8. So we're going to do 6 times 8, 2 times 8, 4 times 8. And then we're going to multiply everything by the 1. 6 times 1, 2 times 1, 4 times 1. Okay, and we're going to put our answers into this grid. So 8 times 6, okay, or 6 8s are 48. 48 is 4 tens and 8 units. So that's how you need to put it into your grid. Okay, 8 times 2 is 16. That's 1 10, 6 units. 8 times 4 is 32. 32. Now the next line down, so hopefully that's quite straightforward so far. The next line down is 1 times everything. So 1 times 6 is 6. So that's 0, tens, 6 units. 1 times 2 is 2. So 0, tens, 2 units. And 1 times 4 is 4. So 0, tens, 4 units. And that's it. Now all we have to do is we have to extend our lines a little bit, okay, just so that we can add these together now. So you need to be very careful here. What we need to do is we need to add up the numbers below the diagonals. So if I show you what I mean, we're going to add up below this diagonal. We're going to add up the numbers below this diagonal. We're going to add up the numbers below this one. And then we're going to add up the numbers below this one. Okay, so underneath this first diagonal we have 4. So I can just write 4 there. Underneath this diagonal we've got 2, 0 and 2. Okay, so basically like what's inside this diagonal column, if you like. 2 add 0 add 2 is also 4. Okay, so that goes in there. We're then looking below this one, so inside here we've got 3 plus 6 plus another 6. Now, if I added 6, 6 and 3, that gives me 15. Okay, if that gives me 15, I put the 5 in there, but I must carry the 1 over to the next diagonal column. So I'm then looking inside this diagonal column here, I'm adding this up. I've got 1, add 8, add 0, add 1. Okay, so 1 add 8 is 9, add nothing, add 1 is 10. Okay, if it's 10, I'm going to put my 0 here, I'm going to carry my 1 over to this final section. And in this final section I've got 4 and 1, so that's a 5. So I'm going to put my 5 there. So as you can see, I've written the numbers, the answers, all along this bottom column here. And I've ended up with 50544. So I'm just going to write that down here, 50544. Now, if I was doing 624 times 81, okay, my answer would be 50,544. But I'm actually doing 6.24 times 8.1. So my answer, even though I've got these digits, I need to put my decimal points back in, And I remember that we had to move it 3 places. We had to put it back 3 places back because that's how many times we took it out. That's how many times we moved to take it out. So what I'm going to do is I'm going to start from the end of my number and I'm going to go 1, 2, 3. So my decimal point would end up there. So my final answer is 50.544. Okay? And that's it for the decimal. So like I say, you can use this method without the decimals and just leave your answer as it is. Or if your question had decimals in it, you would put them back in. Put it back in. Okay? Alright, I know that method can seem quite confusing, but as long as you've got one that you need, so for example, if you've got one that you can use and you're confident using, then use whatever method you feel comfortable with. I'm just showing you these methods so you've recapped them and you've got one to use. Now, just quickly as a reminder, you can still use the grid method, which is the one I showed you on the previous slide, the grid method, to do decimal numbers. You would just do 624 multiplied by 81. And you would do your multiplication as normal, and then you would put your decimal places back in like I did over here. So it's the same concept, you just need to put your decimal points back in. Okay? Okay, so let's move on to some division. Now, using or doing division without a calculator sometimes can be a bit tricky. The first thing that you need to make sure is when you are dividing using long or short division, you need to make sure that some important zeros aren't missed out. I'm going to show you an example. So if we look at 1,435 divided by 7, our answer should be 205, not 25. Now, let me just show you how that will look. So if I decided to use the bus stop method, which a lot of you are comfortable with and have seen before, I would do 1,435 and I'm going to divide it by 7. And that's saying how many 7s go into 1,435. So what we're going to do is we are going to, first of all, split this up into smaller numbers. Now, can I do how many 7s go into 1? No, I can't. Okay. So what I'm going to do is, I can put a 0 there if I want to, saying no. But what I'm going to do is I'm going to say, okay then, well, how many 7s can I fit into 14? Okay. Well, we know that 2 7s are 14. So I'm going to put that 2 there. All right. So I've used those two numbers. So then I'm going to say, can I fit 7s into 3? No, I can't. Okay. So instead what I'm going to do is I'm going to say, how many 7s go into 35? And 5 times 7 is 35, so I can put 5 there. So my actual answer is, as mentioned here, 205. We don't need the 0 at the front because it doesn't actually mean anything. However, we do need this 0 in the middle because it's a significant difference to 25. Okay, 205 is our answer. So here are 2 questions. Why don't you pause the video and have a go at those and then press play for the answers. Okay, these 2 weren't too bad. So if we wrote them out, 255 divided by 5. I can't put 5 into 2, so I can put my 0 there if I want to. But I can put 5 into 25. How many 5s go into 25? 5 times 5 is 25. And then how many 5s go into 5? And that's 1. So my answer should actually just be 51. Okay. And then this one here, 344 divided by 4. Okay. How many 4s go into 3? We can't do that. Okay. Now, it then says how many 4s then can we fit into 34? So this is a little bit trickier. If I wrote out my 4 times table, 4, 8, 12, 16, 20, 24, 28, 32, 36. 34 isn't in the 4 times table. Okay, so how close can we get? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 times 4 is 32. So I can say that 4 goes into 34 8 times. But I haven't got 32, I've got 34. So that's 2 left over. I've got 2 remainders. Okay, so what I'm going to do is I'm going to write my 2 remainder just there. Okay, and I'm actually going to bring down this 4 here to join it, giving me 24. So now I'm just going to say how many 4s go into 24, and that's 1, 2, 3, 4, 5, 6. So that goes there. So my answer for that one is 86. Okay. Again, I'm going to leave some worksheets on your platform so you can have a go at these if you need some practice. Okay, so I've got another example here of division, except this time we're just looking at this example below here. This is the same information I've already talked about. This example down here says that a bar of chocolate costs 74 pence and Caris has £9.82. What is the maximum number of bars that Caris can buy and how much money does she have left? Now in this case, I wouldn't sit and do £9.82 divided by 74 pence. For a start, this is in pence and this is in pounds. So they're in separate units. So I would either have to do 0.74 pence, okay, and do £9.82 divided by 0.74, which looks awful and I don't want to do that. Or I could do 982 divided by 74, okay, because they're both in pence. Still, I would not like to do that either. So what I'm going to do is use a different method, and it's a little bit like chunking. And what that means is, okay, I've got £9.82, all right. How many chocolate bars can I buy for £9.82 if they are 74 pence each? What I could do instead of doing that long division method or short division method using the bus stop, I could think, okay, well, I know that 74 pence times 10 chocolate bars, okay, I should know this, is £7.40, okay, or 740 pence if you like, okay. So this is 982 pence, I just want to remind you. Okay, so I've spent £7.40 or I've spent 740 pence. Okay, fine. I'm then going to have another think and be like, okay, how many more could I buy? How many more chocolate bars could I buy? I'm going to think maybe 3, 74 times 3 I'm going to do. And I can use my quick column method for this one because I can multiply using the column method quite quickly with a single digit number. 74 times 3. Okay, 4 times 3 is 12. Carry the 1. 7 times 3 is 21. Add the 1 is 22. Okay. If you didn't want to use that method, you could do 74 times 3. Okay, 3 times 7 is 21 plus the 0. And 3 times 4 is 12. Add them together. 210 plus 12 is 222. Okay, so I'm just giving you different ways that you could work this out rather than doing a division. So 74 times 3 is 222 pence or £2.22. Okay, right, so far then you've spent 740 pence or £7.40 and 222 pence or £2.22. If I add those together, gives me 2, 6 and then 9. Okay, so altogether I've spent £9.62. Okay, so I'm just putting those pences back into pounds. Now, can I buy any more chocolate bars? I've spent £9.62 and I've bought altogether, if I look up here, 13 chocolate bars. Okay. I can't buy any more because I've only got £9.82 anyway, and I've spent £9.62. So the maximum number of bars she can buy is 13 chocolate bars. Then says how much money does she have left? Now it's up to you whether you just want to quickly work that out in your head, or if you wanted to, you could, if I just change my colour so that you can see this, you could do £9.82. Take away £9.62, okay? 2 take away 2 is 0. 8 take away 6 is 2. And 9 take away 9 is 0. So you are left with 20 pence. 20 pence left, okay? You probably could have worked that out in your head, that bit. Okay, so you don't actually have to divide. You could times and work out an estimate, all right? And then trial and error in order to get your answer, okay? All right, so now just a few things to point out here. When dividing by decimals, it's often simpler to write an equivalent calculation using whole numbers. So instead of just doing it like via chunking, let's say you got a question like £372.80 divided by 0.4 or 40 pence, okay? So 372.8 divided by 0.4, you could have times them both by 10, which means the decimal point would have moved, and it would give you 3,728 divided by 4. Okay, because you've multiplied them both by 10, doing that calculation would give you exactly the same answer as if you did this calculation. And let's say you had 527.1 divided by 0.02, if we multiplied them both by 100, so we'd move that decimal twice and that one twice, you would end up with 52,710 divided by 2, so all you need to do is half that number, and it'll give you exactly the same answer as if you'd just done this calculation here, okay? So calculating the answers to some word problems might involve several steps or calculations. So let's have a look at the example I've got on the next page. Okay, so example, this is the menu at a football stadium. lattes £2.45, cappuccinos £2.20, frappuccinos £2.60, panini £3.70, and cheese and ham toasty £3.45. Harry and his friends buy 2 lattes, 1 cappuccino, 3 paninis, and 1 cheese and ham toasty. Harry hands over £30. How much change should he get? Okay, so with this one, if you'd like to pause it and have a go, please do that. And then press play for the answer. All right, if you've done that, let's go through it. Now with this question, what you could do first, and you know, this is completely up to you how you tackle this, is you could write down everything that they buy. So it says that Harry and his friends buy 2 lattes. So that's £2.45 plus £2.45. 1 cappuccino, which is £2.20. All right. 3 paninis, so £3.70, £3.70 and £3.70. And 1 cheese and ham toasty, which is £3.45. Okay, I think that's everything. Now what I would do here is I would actually split up this one and this one. I wouldn't sit and add all of those together like that. So what I'm going to do is I'm going to do £2.45 times 2. Okay, now you could work that out in your head if you wanted to. £2.45 times 2. Okay. 5 times 2 is 10. Carry the 1. 4 times 2 is 8. Add the 1 is 9. Put my decimal point in, and 2 times 2 is 4. So that's £4.90. So I'm going to write that there. I'm then going to do £3.70 times 3. Again, you could do this using the grid method or the lattice method, whichever. Okay, you could, and then, so if I show you, we could do £3.70, we could do it like that. You don't even need the 0 on the end if you don't want to. Times by 3. If I did the lattice, like this instead. Okay, 3 times 3 is 9. 3 times 7 is 21. And 3 times 0 is 0. Remember, we add up below the diagonals, so we've got 0, and then here we've got 1, and then under here we've got 9 add 2, which is 11. Okay, but because it's £3.70, we've had to move the decimal place twice to get rid of that, so we have to put it back in twice. So it's actually £11.10. Okay. If you wanted to do that using the column method instead, £3.70 times 3. 0 times 3 is 0. 7 times 3 is 21. Put the 1 in, carry the 2. Put the decimal place in. 3 times 3 is 9. Add 2 is 11. So you still get £11.10. All right. You've got to get confident using a method. So choose one and practice it. Okay, so this is £11.10. Okay, so what I'm going to do is I'm just going to rub out some of my working out over here. I'm sure you've written it down already if you're taking notes. Okay, if not, just rewind and pause and do that. Okay, so now I've actually got £4.90. I mean, you could have added them all up separately if you wanted to do it, it's up to you. Plus £2.20, plus £11.10, plus £3.45. And now I will add them all up. So this column is 0, add 0, add 0, add 5, which is just 5. This column is 9, 10, 11, 12, 13, 14, 15, 16. Remember, 16 is 6, 10 and 6, so we carry the 10 over. This column is 4, 5, 6, 7, 8, 9, 10, 11. Carry the 10 over, and this column is 1, and then plus this 1 here, which is 2. So your answer is £21.65, which is the price for everything they bought. Okay. But it says how much change should he get? Now again, this is up to you how you want to work this out. You could either think, okay, well, I know that if he spent £21.65, okay, there's only 35 pence left up to £22. Okay. So he'll get his 35 pence, and that takes us up to £22. And then from £22 up to 30, it's £8. So altogether, his change would be £8 and 35 pence. Okay, and we'd write that as £8.35. You also, if you wanted to, could have done 30, and I would have done it like that, take away £21.65. But that probably would have been a bit longer winded, because what you would have had to do is, because all of the top numbers are zeros, we would have had to taken a 10 from this and turned it into a 2, and then made this into a 10, this 0. We'd have then taken from that and made that a 9 and made that into a 10, and taken from that and made that a 9 and made that into a 10. Okay, because you need that 10 to do 10 take away 5. 10 take away 5 is 5. 9 take away 6 is 3. 9 take away 1 is 8. And 2 take away 2 is 0. So you still would have got £8.35 anyway. Okay. So just be very careful when you're working things out without a calculator. A lot of you are very good at things like that. So, just choose a multiplication and a division method and try and practice it. Okay, well done. Okay, so I hope you feel confident with rounding to 1, 2 and 3 decimal places and significant figures, as well as using written methods to add, subtract, multiply and divide by 2 and 3 digit numbers, including decimals. I hope you also feel confident with multiplying and dividing by powers of 10, which, once you get the hang of it, is really quite simple. And you feel confident estimating and approximating. Now, the last thing that I'm going to say here with estimation and approximation is that you might need to use this to check your answers. So if it asks you to do that in your exam, then please do so. So if it asks you for a check, you can either do a reverse calculation or you can use estimation. Okay, so you can round your digits to a certain amount of significant figures, usually 1, and then you can estimate it. Okay, so good luck with your questions in your assignment based on this learning outcome, and I'll see you in the next video.